First, in I, the question asks us about the explanation or the meaning of a ligand. And so, a ligand is a species that uses a lone pair, so has a lone pair, to form a bond with a metal ion. I'll be using some examples to explain more what is a ligand. However, explaining a ligand and defining it will let us gain 1 mark from the 2 marks of this question. For example, water is an example of a ligand because it has 2 lone pairs, and also ammonia is an example of a ligand because it has 1 lone pair that can be donated to a metal ion to form a complex ion. And notice how I said donated because a ligand donates the pair of electrons, which brings us to the second part of the question, which asks us to describe the type of bond, and the type of bond is dative or covalent or coordinate, sorry. And so we can use either of these. They're synonyms, which means that it's a covalent bond where only one atom or one species shares the electron, shares the 2 electrons, and so a ligand donates its lone pair, and the metal ion does not contribute to this covalent bond. Stating if it's dative or covalent will let us gain 1 mark. Moving on to the next part of the question asks us about the oxidation numbers of coppers in 2 different species. So I'll be solving the first oxidation number on the left side and the second oxidation number on the right side. First of all, for this species, we will have to realize that the charge for NH3 is neutral, so it's 0, which will help us find the oxidation number of copper. Therefore, the oxidation number of the 3 ammonia molecules will be 0 times 4, which will be 0. And Cu is our x. I'll be putting it as a variable of x because this is our unknown, and we know that the whole species will have an oxidation number of positive 2. So x plus 0 equals to 2 plus minus 0 minus 0, which will allow us to see that x equals 2 plus, and so the oxidation number of copper is 2 as plus 2, and it has the plus must be before the 2 because it's an oxidation number, and this is how they are written. And so for the second species, we will do the same. However, we will realize that the Cl4 is in group 17, meaning that it gains 1 electron to become to achieve the octet rule. So it has a charge of -1, and I have 4 chlorine atoms, which allows us to see that it's 4 minus -1. This is the charge of four Cl atoms or ions, sorry, and our X is also the oxidation number of copper, and we will realize that the whole oxidation number of this complex ion is -2. So we'll realize, that it's -4, so the negative with the positive will make this negative, and this is 2 minus, so we will have to add 4 on both sides. So this is 4 minus 2, which allows us to see that the oxidation number here is also 2 plus. However, we should also write it in the same way we have written this one, where the plus is before the 2. The third part of the question is asking us why the species in II are colored, and let's have a look on the species in II. We know that they are complex ions, meaning they have a ligand and a transition metal ion. And we know also that the characteristic of being colored is attributed to the transition metal, to the presence of the transition metal ion. Before seeing the necessary information to achieve the 3 marks, I will just briefly explain how is a color observed through the transition metal ion. First of all, the 3D orbital diagram is shown below, and First of all, when a ligand approaches the metal ion, the 3D sublevel is split into two sets of energy levels at different energy levels, and this is how they are supposed to look like. They are still 3D, but they are just split into a higher energy sublevel and a lower energy sublevel. And so how is a color observed? When a part of the visual spectrum, or when a light is absorbed by electrons, they move through energy levels from a low to a high 3D energy level. And so a color is absorbed. When the color is absorbed, the complementary color is observed. So the energy difference corresponds to a wavelength of visible light. So if the blue color is absorbed, or if the blue wavelength is absorbed, the complementary color will be seen, which is orange. This is seen through the color wheel in the data booklet. However, this is just a brief explanation, and now we will see the 3 marks needed to explain why the species is colored. First of all, we need to say that the d orbitals split into 2 sets at different energy levels. And then we have to say chronologically what happens next. We said that a part of the visual spectrum visible spectrum is absorbed by electrons. And then what happens next? We said that electrons move between energy levels, or we can say from a lower to a higher energy level. And then lastly, we said that the energy difference corresponds to a certain wavelength of visible light. And these are all points that are justified by my explanation. However, they can be worded in any way. However, these any 3 points of these should be targeted to get the 3 marks. And this is how we solve this question. Thank you.